Okay, now let us start a new chapter, new topic in +1 physics, projectile motion. Anybody, not a person, anybody or object that is thrown or projected is a projectile. If it is discharged, that is thrown on the surface of the earth at an angle theta to the horizontal, it will describe a parabolic flight path if theta is less than 90 degree and initial velocity is less than the escape velocity. This part we will discuss in subsequent lectures. Now there are two types of projections: projected horizontally from a height h. We can throw a projectile horizontally from a height h from the ground. The second is it can be projected from the ground making angle theta with the horizontal. This we will discuss in another lecture. Now I am concentrating on this. Now look at the diagram. This is your horizontal, this is your ground. From O to A is height h. From this point, one is projected with a velocity u, shown in red. Let it be 7 meters per second. Means it will travel 7 meters in 1 second. And at the same time, another is projected with a velocity v at the same time. Look, if from here to here represents 7, this length, this green one, is almost 3 times this. So 7 times 3 will be 21 meters per second. If you take this 10, then this will be 30. So this is thrown from here, this one is thrown from here at the same time, and at the same time another one, the third one from this point is just dropped like this. It just dropped like this. It just dropped like this. Not thrown downward, like this. So now to this side earth is pulling 3 of them. So to this side the acceleration is g, and the value of g is 9.8 meter per second square. What is the physical meaning? Means in every second the speed will increase by 9.8 meter per second. If you take this as 10 meter per second square, the physical meaning is in every second the velocity will increase by 10 meter per second. In every second the velocity will increase in 10 meter per second. Now to this side there is no acceleration, because this object, they don't have an engine inside it, somebody is not driving it, and there is no air resistance also from this side. Now the question is, what my argument is, this first one, this is second one, and this third one, which is just dropped from here, then all of them will reach the ground at the same time. Why? This one, to touch the ground, has to fall a vertical distance from here to here, that is same thing as h. The second one, to touch while touching the ground at b dash, will travel a vertical distance same h. And the third one, which is dropped from here, will also travel a vertical distance h. So all of them, 1, 2, 3, will travel the same vertical distance h. Now the question is, you might be thinking this would, because the speed is more here, so it will arrive earlier. The speed is less here, so it will arrive little later. It's not like that. Now look, the red one, which is thrown from here with a velocity 7 meters per second, just at the instant you threw it, what was its velocity at this point downward? 0. Similarly, this second one, which is thrown from here with a velocity v, this I have taken for understanding only. The second one, which is thrown from here with a velocity v, at the time of throwing, just the moment it lifts your hand, What was its velocity at this point downward? 0. So both this as well as this, at the starting point they had initial downward velocity 0, and the third one, which is dropped from here, has the same initial downward velocity 0. Both of them, all of them have the same initial downward velocity, and three of them have to travel the same vertical distance, that is h, and for three of them the downward acceleration is same, therefore they will arrive at the same time. Now so this is what I have explained here. What I explained I have just written here. U, velocity of projection of the first one, velocity of projection of the first one, B, velocity of projection of the second one, and a third one just dropped from A, which I just explained. Three of them at the same time, at the same instant of time. All three will reach the horizontal surface OX. This horizontal surface OX means third one will reach here, first one will reach here, the second one will reach here at the same time in the absence of air resistance, which I will explain, which I just explained in the video now. Now let OA, from O to A, let from O to A is H. For the third one, the initial velocity at A is 0. For the third one, at this point, initial downward velocity is 0. 0. So, for the third one, initial downward velocity is 0. For the third one, initial velocity at A is 0, that is downward. G is equal to this, which I take it as 10 meter per second square, that is the down on acceleration. I will not put this value, I will just use the value, I will just write the symbol G. We know equations of motions, S is equal to ut plus half at square. I am now calculating for the third one. At the point A, the third one, which was just dropped from A, the initial velocity downward at the point A was 0. That will gradually increase as time passes on because of this acceleration. So using this, S is equal to H, this distance is equal to H, U is 0, so 0 into this thing is 0, half. Instead of A, I write G, half GT square. So your H is equal to, half GT square, cross multiplying I get T is equal to 2H over G square root. 2 is constant, G on the surface of the earth is constant, so its T is proportional to square root of H. Now, now in the horizontal direction, the motion along the horizontal direction, in this direction there is no acceleration. So, in the horizontal direction there is no acceleration or retardation, there is no air resistance also. So, S is equal to ut plus half at square gives S is equal to ut plus half. Instead of A, I write 0 because there is no acceleration, this whole thing becomes 0. So I am left with S is equal to ut. So I am left with S is equal to ut. So where S is the distance traveled. Now for the second one, sorry, for the first one, the distance traveled in the horizontal direction is from O to B. So OB is equal to this speed into time, U or T I had just derived 2H over G square root. Now the second one is arriving here. So the distance from O to B dash. So from O to B dash is equal to speed into time. So T is equal to this. So because this part is 0, so in this direction there is no acceleration, so only this part remains. So displacement S is equal to, distance traveled is equal to just speed into time.